So today we are talking about regular polygons, what they are, and how we can find their area and their perimeter. So first, does anybody know what it means when we say a polygon is regular? Any guesses on that? Mia? So all of the sides are congruent. That's part of it. And all of the angles are congruent. So an equilateral triangle is a regular triangle. A square is a regular quadrilateral. But a rectangle where the length is longer than the width is not a regular quadrilateral. A rhombus is not a regular quadrilateral unless it's also a square. We are also going to be talking about regular pentagons, hexagons, decagons. If I drew a pentagon that looked like a house, that is not a regular pentagon because some of the angles are 90 degrees and some of them aren't. So they have got to have all of the angles and all of the sides congruent to be a regular polygon. We are also going to talk about inscribed and circumscribed. Inscribed means it's drawn inside another shape. So in this picture, the pentagon is inscribed and the circle is circumscribed because circumscribed means it goes around the circuit on the outside of it. I could also draw one where the circle is on the inside and the pentagon's on the outside, and then the circle would be the inscribed one and the pentagon would be the circumscribed one. Our new vocabulary word today is apithom, and an apithom goes from the middle of that polygon straight to one of the sides. Right in the middle of the side, it bisects it, it makes a 90-degree angle down there. Notice that when the pentagon is on the inside, that apithom is not the radius of the circle. It does not go all the way to the circle, does it? So here, the apithom in blue is shorter than the purple, which is a radius of the circle because it does go all the way to the circle. When I have them drawn this way, the apithom is the same as the radius of the circle. So you're going to have to read some of these problems carefully. Which one is inscribed, which one's inside, which one's outside? So any questions on regular and apithom? Those are our new words today. Chloe. It goes from the center. Easiest way is the picture definition. It goes from the center straight to one of the sides, and it bisects those sides, so it's right smack in the middle, and it forms a right angle. And we're only talking about these with these regular polygons in order for it to bisect those sides like that. So our challenge for today is we are going to be looking at figures like this. So here's a regular pentagon, and we want to find its area. So far we have formulas for areas of triangles, and we have formulas for some different kinds of quadrilaterals, parallelograms, trapezoids, regular old rectangles. But so far we've not had any kind of a formula or any way of getting the area of a pentagon. So I've drawn it just to keep track of what information they've given me. The pentagon is inside the circle. The radius of the circle is 6, so I'm going to draw that to one of the vertices of the pentagon because that might help me more than drawing it some random place like that. That doesn't look like that would be real helpful for the radius. So I try to draw it at a selective point that's going to be helpful for this problem. So my pentagon. I need area and I need perimeter. I've got 5 sides. I need some help with some strategies for getting that area. Anybody have any thoughts of what we might be able to do to figure out this area? Okay. Whoa, I don't have any triangles. What in the heck are you talking about? Okay, so let's start with that, and then let's decide what we're going to do. So we can break this pentagon up into 5 congruent triangles. So let's see if I can get all of these in the right spots here. I think it needs to go there, this one down here, this one over here. So is everybody good with, we've got 5 triangles, and so if I can get the area of one triangle, I can say that the area of the pentagon is going to be 5 times the area of one of those triangles. Okay, now before we do too much more, what are our, don't worry about this little circle yet, what are our formulas for the area of a triangle? What's one of them, Ronald? So one of them is going to be that the area is the base times the height divided by 2. And if I want to use that one, I need to get this base, so one of the sides for the perimeter, and I need to get this height, which is the apithom for that pentagon. What is our other formula for the area of a triangle? Chloe. I'm just going to put in a sine C on there, whatever we want to call it. And in that case, it would be like, this is my angle C, and this is A, but what's going to be true about this side? Is it going to be different from A? It's really going to be A, so that formula is going to become 1/2 A squared sine C. Now, you guys are in an advanced track. That means you've got smart brains. And my advice to you on these problems is use those smart brains and make life easier on yourselves. Some of these problems, 1/2 BH is easier. Some of them, 1/2 what is now going to be A squared sine C will be easier. It's going to depend on what you are given in the problem. So for this particular one, let's look at what we know so far. We know that this radius is 6. So we know this radius is also 6. So if I could only get that angle in between, if I could only get this C up here, I'd be in great shape to use this second formula. Blake. Yes, how'd you come up with that? So if I look at those apex angles at the top of that isosceles triangle for the one that I first drew down there at the bottom, that's called an apex angle. And there are 5 of those that meet in the center of the pentagon. They're all congruent. Circle sum, all 5 of those put together make 360. So any one of those has to be 360 divided by 5, which is 72. So all that we need to do to solve this problem is to plug in on the calculators 1/2, and then we have 6 times 6 times the sine of 72. And in all honesty, I'd say 36 divided by 2 is 18, and I'd just enter 18 sine 72 on my calculator. Ryan, what'd you get? 17. Is that what others got? Oh, yes, what did I leave out? Read. That's going to be the area of one triangle. So the area of 5 triangles will be 5 times that. So now enter that, and what do we have? Or just take what you had times 5. Now what do you have, Ryan? 85.595, and my units were feet, so this area is square feet. Everybody good there? Okay, this problem, however, also asks us for perimeter. So I think I'm just going to make a second copy of my figure here and move that down a little bit lower. So that we have more room to see what we're doing. Okay, now I need to get the perimeter. So what information am I missing that I need to figure out, Aiden?
The length of the
of any one of these sides or the base of that isosceles triangle. How am I going to get that? Need some help coming up with some ideas. Grace. Okay, so take half of a triangle. This was 72. So now I'm going to take half of that. And so this will be 36. And if that whole side was B, what I'm doing now is I'm splitting that into two little pieces, right? And I know that that's 6. So which trig ratios should I use to be able to figure out A in that little triangle? So we're going to use sine, because opposite over hypotenuse. So the sine of 36 degrees is opposite over hypotenuse. So side A is 6 times the sine of 36 degrees. Now to get the perimeter, I needed 5 of the long sides, which were B, but each B is 2A. So I need 5 times 2 of those A's, or 10 times 6 sine 36, which means 60 sine 36. And what do we get? Zoe, what'd you get? That makes sense to everybody? Okay, I'm going to do a couple more of these examples. Okay, this time we have a decagon, 10 sides, and any one side is 12. Now, and we don't have to worry about inscribed circle or anything on this one. The decagon is enough there. Now, I don't know about you, but unless I had the software that you see in this program, I'd have a hard time drawing a decagon. So if you want to on one like that, you can say that you have, how many of these triangles would I have if it's a decagon? So you might just draw one of these, and you might make a note. I need 10 of these triangles, and so far I know one of those sides is 12. How big is my angle up at the top here going to be? Because I've got 10 of those triangles coming together, and 360 divided by 10 means the top of that is 36 degrees. Okay, they don't ask us for the perimeter on this one because that would be too easy, 12 times 10, and we'd be done. So they're just asking us for the area. So I need to decide, is it going to be easier to get H and use 1/2 BH for one of those triangles? Or is it going to be easier to get one of these hypotenuses, whatever I want to call it, and then use that? So this triangle, I've got 36 degrees here. If I split it in half, I'm going to have 18 degrees. That's not one of our special right triangles. So this H is going to end up having one of my trig ratios in it to get it, right? So if I do 1/2 BH, I'm going to have 1/2 times 12 times this thing with one trig ratio. If I do 1/2 c times the sine of the angle in between, I'm going to have a trig ratio for c, right? So somehow there's going to be a trig ratio in there. And then there's also going to be sine 36 in here. That sounds a lot messier to me to have two of those trig ratios running around in it. So when they give me one of the sides of the polygon, I'm probably going to want to use 1/2 BH for my triangle formula. So I need, for the area of the decagon, to take 10 triangles, and for any one triangle, I'm going to do 1/2 BH. So if I want H, we said this angle up at the top is going to be 18 degrees. How big is the short leg of that triangle? It's going to be 6. So which trig ratio am I going to use to get H? So the tangent of 18 degrees will be 6 over H, opposite over adjacent. So one diagonal, I can switch the H and the tan 18. So H is 6 over tan 18 degrees. That means when I plug in here, I'm looking at 10. For my 10 triangles, how big is my base? For my 10 triangles, the base is 12. Got to be careful there. And then I have this height, 6 over the tan of 18 degrees. Okay, let's clean that up a little bit before we enter it on the calculator. 10 times 1/2 is 5 times 12 is 60 times 6 is, so please enter 360 divided by the tangent of 18 degrees, and let me know what we get for this area. Lynn, what do you have? And these were centimeters, I think. Yes, so square centimeters. So that one makes sense. Okay, one more example. Perimeter is 42. It's a regular hexagon, and I need the area. So I think I've figured out by now that I'm generally talking about doing my triangles. So my area for the hexagon needs to be 6 triangles. And I've got a choice of formulas for a triangle. I don't have anything labeled on this picture. All I know is that the perimeter is 42. Does that help me? Olivia, how does that help me? So 42 divided by 6, each of these sides is going to be 7. Okay, so I'm getting there now. I know the base of one of those triangles. And most of the time I've been needing to get that angle up at the top. Do I need to do that again? Emily B., what will my angle up at the top be this time around? Which is? So this is 60 degrees. Now what should we do? I could, but I'm tired. That's too much work. Make it easier on me, please. This one is special because it's a hexagon. So tell me about these two sides. So these two have to be the same, right? Which means these two angles have to be equal. But if the top angle is 60, what are those two base angles? Okay, so now, what else do I know about this triangle? 360-degree angles on the bottom side is 7. What else do I know? all of the sides are 7. So do you really want to do 1/2 BH on this one? No. So for this one, let's do our 6 triangles, and let's do 1/2. 7 times 7 times the sine of the angle in between those two 7s. So let's see, 6 times 1/2 is 3. So let's enter 3 times 49 times the sine of 60 degrees and see what we have. Anna, what do you have?
127.306 feet.
Any questions on what we've done?